Hi friends, I am developing this video based on Anna University Ansys Practical Simulation Laboratory. With these videos, you can enhance your problem solving skills using Ansys Apdl mechanical software. I have already posted various videos on various exercises. Now, we have an exercise of cantilever beam which is subjected to a point load and uniformly distributed load. Okay, how we can solve this type of problem using Ansys software, analysis software. First, open Ansys, go to preferences, select as structural, since it is a structural analysis, press OK. The next thing is to go to preprocessor, element type, add, edit, delete, add. Since it is a beam analysis problem, you have to select beam and click OK. Close this one. The next thing is to give the material properties of the beam. What is the material properties? As you can see in the question, the material is steel. So go to material properties, material models, structural, linear, elastic, isotropic. 2E5 is the smallest of the steel, whereas Poisson ratio is 0.3. Click OK. Close this one. Next thing is to define the cross section of the beam. For that, go to sections, beam, common section. It is asking the breadth and height. What is breadth and height? 100 by 200. 100 is the breadth, height is the 200. Okay. Raise it down. Breadth is 100 and height is 200. Click OK. Now the cross section has been defined and stored in the Ansys. The next thing is to model our structure or beam. So go to modeling, create key points in active coordinate system. This is asking the key point number and the x, y, z coordinates. The z coordinate will not be used, only the x and y coordinate will be used. Now we have to create a key point at the start point. For that, raise it down. Key point number 1, 0, 0. Apply. And the node has been key point has been created here. The next key point 2 has to be created at a distance 2000 mm from this key point. Okay. So 2000. Apply. Now the key point 2 has been created here. The next key point similarly 2000, 4 plus 2, 6000. So you have to create a key point here. Okay, 6000. Key point number as 3. Apply. The next thing is total length. Okay, total length 2 plus 4, 6, 7. So 7000. Number 4 key point at 7000 distance from the initial key point. Okay, click OK. 7000. We have created the 4 key points. Now we have to join these key points using the line. For that, go to lines, straight line, select this key point and this key point, select all the key points, press OK. Now we have joined this key point using the line. The next thing is to mesh the entire line to convert into elements and nodes. For that, go to close the modeling and go to meshing. Under size control, manual size, lines, all lines, entire lines have to be meshed. I am giving the element divisions as 15 or 10. Click OK. The component is meshed. No, this component is divided to the what number of element divisions I am given. The next thing is to mesh the entire component. For that, close this line control, go to mesh, lines, select all lines, 3 click for selecting a lines. Click OK. The entire beam has been meshed. Okay. Now the next thing is to give our boundary conditions. What are the boundary conditions? 25 kilonewton at a distance 2000 and 40 kilonewton at a distance 6000 and 15 kilonewton per meter, which is a uniformly distributed load at a distance 4000. Okay, now we can give. For that, first we have to give our point load. So for boundary conditions, you have to jump from preprocessor to close the preprocessor, go to solution, define loads, apply structural. Since it is a cantilever beam, this end has to be arrested in all degrees of freedom. Okay, for that, displacement on key points, select this key point and press OK. Under this, all DOF to 0, which is all degrees of freedom to 0. Click OK. Now I have arrested all degrees of freedom at this key point. Now have to give the loading conditions, force and uniformly distributed load. For that, click force on key point, select this key point, only that key point will be selected, press OK. We have to give the load in the negative y direction. To represent the load in negative y direction, we have to give it as direction of force Fy, and the minus indicates the negative y direction force, and the value what we give is 25 kilonewton, but we have to give as newton, so 25,000 newtons minus negative y direction 25 123,000 newtons. Okay, click OK. Now we have got a point load here. Okay, yes. Then next we have to give a point load here at a distance of 6000. Okay, yeah. For that, again go to force key point, select this key point. You can click anywhere, but it will select this key point alone. Click OK. Fy as 40,000 minus 40 1 2 3 minus 40 1 2 3. Okay, click OK. Now the boundary conditions are given. Okay, the next thing is uniformly distributed load. Okay, for that you have to go to pressure on beams it is asking to select the element. Okay, for that, see, from this point to this point. Okay, so now I have to select from this point to this point. So you can also use box type. Select this box and in this type you can also select, or on beams select the elements likewise. Okay, then click OK. It is asking the I and J node value. What is the value? 15 kilonewton. Okay, so 15,000 newton raise hidden 15,000. If you change the value of J node, it will be indicated as uniformly varying load, whereas when I node and J node are given as same value, it is known as uniformly distributed load. The load key, it is a very important factor. What is this factor? The load key 1 represents the loading conditions in x direction, and load key 2 represents the loading condition in y direction, and load key 3 represents the loading in z direction. But what is necessary criteria? We need loading conditions in y direction. So I'm giving as load key as 2 and pressure value at node as 15,000 and click OK. Now from here what I have selected, from here to here the uniformly distributed load has been subjected to a beam. In this way the UDL has to be given using Ansys. Now the loading conditions are done. Okay, now the loading conditions are done. The next thing is to solve the current LS. What is the current LS? Current load step. For that, define loss, close this define loss, solve current LS, press OK. Solution is done. When there is any error, it will be indicated here. Close this one and close this one. Now we have to review the results. To review the results, you have to jump from solution to general post processor. Under post processor, go to plot results, deform shape, deform test undeform, click OK. Now the beam is deflected likewise. Okay. Now we can also determine the stress and displacement. For that, go to nodal solutions, DOF solutions, displacement vectors and click OK. Okay. Yes. The next thing is stress. On my stress, click OK. The next thing is to review our shear force and bending moment diagram. For that, go to element table, define table, add by sequence number 3, apply by sequence number 6, apply by sequence number. I also forgetted it. If you forget the same way what I have done, go to Ansys help. What I will explain what are those numbers, SMIS numbers. Go to help. Wait a minute, the Ansys help is loading. Under this, search as beam 188 and search beam 188. Double click is this one. Then at the last you will see these numbers. See SMISC. For shear force in y direction, the numbers are 6 and 19 at I and J node. Bending moment is 3 and 6, 3 and 16. So 3 and 16. So 16 and 19 has to be given. Okay. 3 and 6 have been given. Add 16. Apply 19. Okay. Close this one. To plot shear force, plot results, line element table. Under control plot line element result in I and J node. Say I and J node. For shear force Y, 6 and 19 has to be selected. 6 and 19. See, this is the shear force diagram. Okay. Bending moment diagram, 3 and 16 has to be selected. So this is the bending moment diagram. When I refine my mesh very accurate and very minimal, these steps will be avoided and the straight curve will be shown here. I have not refined my mesh to the maximum extent, so only slight step has been came. In this way, we can able to solve this type of problem using Ansys Apdl software. Thanks for watching. Have a nice day. Subscribe my channel if you